Okay, hello everyone. Good evening, everyone. Please, we'll need to give some other people time to join us. Okay, people are just requesting for the link, so we have to give people time, just like 5 minutes. Okay. Okay, I can see Okereke, I can see Blessing, I can see Folake, Darasimi. You're all welcome. Like I said, just few minutes for others to join in. Okay. Yeah, good evening, everybody that is just joining. Okay, so I'm about to share my screen, but I like to be sure that you can hear me. So if you can hear me, just state it that you can hear me. Okay, very good. I might be a bit distracted because you guys are still not up to the number of those that have registered, but we have to start. Okay, so I like to hear some of the things that we learned last week. Chemistry. Can somebody tell us the topic and something that you learn? You can type independently. I'll be here to watch you type them. So the things you learned our last chemistry class, I want to be sure that you guys followed in the last class. Yeah, separation of mixtures. You can say something about it. Any of the methods. Okay, separation of insoluble solids. What is that? Say something about it. I'm waiting. Everybody should say something. Filtration, decantation, and centrifugation. Okay, that's very good. Darasimi says the different ways to separate mixtures based on such things like the size, the composition, like ion, like object. Okay, that's very good. Yeah, any other person? I'll be waiting. I'm waiting. Okay, Blessing says the topic was separation of mixtures, and I learned how to separate them based on their features. I like that. I like this. Yeah, based on their features. Insoluble solid, exactly. Example, filtration, decantation, sedimentation. Okay. Okay. But I would like to say that sedimentation and decantation is the same thing. The ability to allow dust particles or particles to settle at the bottom is called sedimentation. So it's the same as decantation. Okay, this is good. This is making sense. Okay. Yeah, another person says Separation of soluble solids include evaporation, crystallization. Okay. Oh, that's very good. That's very good. Now, those of you that are just saying um, soluble solids. Now, when you say soluble solids are, you should say soluble solids in a liquid. Yeah, soluble solid from its liquid. That would help us understand it. So the next thing I like to, let me share my screen quickly. Okay, please let me know if you can see my screen. Okay, very good. Now, if you remember in our last class, I actually stopped at um, crystallization. Okay. Now, before I continue, there is one that we missed. I didn't mention it earlier, so let me mention it now. Sorry, my pen is not writing. Let me install the pen. Okay, while I'm trying to, okay, somebody said it's a bit laggy. I hope you can see it now. Yes, for miscible, Chinelo, for miscible and immiscible deal. So give me a second, please. Okay, please. You can't see my screen. Okay. You can't still see my screen. Okay, how about now? Okay, can you see my screen now? Hello, can you see? Okay, good. Yeah, so the next step I wanted to talk about is sieving. Now, sieving is used to separate solids of different sizes. It's used to separate solids of different sizes. Okay, with the use of a sieve. Application is Gary industry and cement industry. That's the application, Gary industry and cement industry. Okay, so that's what sieve is. And many of you know what a sieve is. When you have solids of different sizes, you put it in a sieve and begin to shift it. Okay, maybe I should add this. The fine particles pass through the sieve. While the coarse particle, okay, so the one that pass through the sieve are called fine particles, FINE, and while the ones that remain are called coarse particles, COUE. Actually, it should be COARSE. Very important. The person asking for the topic is separation of mixtures. Okay, so please, before I move on, if you understand this, please indicate, say, yes, I do understand, before I move to the next one. Okay, very good, very good, very good, very good, very good. Okay, so that would lead us to the next thing, fractional crystallization. Now, if you remember what I explained last time about crystallization, we said that crystallization is one of the methods you use to separate a soluble salt from a solution. That means a salt that is soluble from its solution. Like when you have salt in water or when you have sugar in water. And I remember that I told us that how to do that is that you concentrate the solution first. Make sure that the solution is concentrated. Once you have okay, so once you have saturated the solution, the next thing for you to do is to put that solution in a fridge, in a refrigerator. Once the refrigerator cools the solution, the salt will crystallize out. Okay, about crystallization. I can see someone in a question, why is Gary sieved when it is in powdered form and can pass through sieve? That's a very funny question. Now, Gary, after it's been made, the particles are not regular. Some sizes are big, some sizes are small. And it's not going to look fine selling Gary like that. So you want everything to be smooth. And the only way the only way you can make everything to be smooth is by removing the big sizes. So when you put it in a sieve and shift it, the tiny sizes, the one that is fine, that's why when you go to market to buy Gary, the particles are very fine, they are very smooth. Unlike, and the reason why it is smooth is because the bigger particles that would have made it rough has been removed by sieving. Gina, I hope you understand that. Okay, good. Now, the next thing is fractional crystallization. So, fractional crystallization is the same thing as crystallization, but the difference is that in fractional crystallization, there is more than one salt in that solution. There is more than one salt in that solution, soluble salt in that solution. So, as you are reducing the temperature, the salt, when it gets to a particular temperature, the first salt will come out. When it gets to another temperature, another salt will come out. When it gets to another temperature, another salt will come out. So the only difference between crystallization and fractional crystallization is that in crystallization, only one soluble salt in the water. But in fractional crystallization, you have two or more soluble salts in water, and you need to separate all of them. Okay, that is what you should know. That's the only difference between the two. Now, if you understand it, say I understand. If you have a question, ask your question. Give me a second. I need to use the bathroom. Just a second, please. Okay. Okay. Very good. Very good. Very good. Now, I like you to see here the different stages. The impure solid is dissolved in the solvent. The solution is heated to evaporate most of the solvent. That's to concentrate the solution. I told you guys there are two ways to make a solution concentrated. It is either you keep adding the salt until it can no longer dissolve, or you heat the solution until water is evaporated until it becomes concentrated. Now, the third one says the hot solution is allowed to cool. The solid appears as a pure crystal. Can you see that? The cold solution is poured off to obtain the crystal. The crystal may be dried by pressing them between sheets of filter paper. So that is how to go about it. I've already explained that. Now, but I have something to say there. Is somebody saying I should open the message box? I think the message box is open. Okay. Now, I want you guys. Okay, so I want you guys to note something very important is that number one is that crystallization is used whenever they want a very pure substance, a pure salt. That is why crystallization is used in sugar industry. That is why crystallization is used in salt making. So the first thing you should note is that crystallization is used whenever purity is desired. Let me write it down. So anytime you want to obtain a very pure salt, high purity, then you must use what? You must use crystallization. I hope that makes sense. Okay. Now, that's the first thing I want you to note about crystallization. The second thing I want you to note about crystallization is that, okay, so salt obtained by crystallization always contains water of crystallization. Now, for those of you looking for example, it's just like if I have water and I have different salts like sodium chloride, I have sugar, I have magnesium sulfate, all of them inside water. I want to separate sodium chloride, sugar, magnesium sulfate from water. The method I will use is fractional crystallization because you have more than one salt you want to separate. You have more than one substance you want to separate. Do you understand? Please don't bother yourself with menthol crystals. That's not our scope here. Chinelo, do you understand? Okay, Dara Simi understands. Rubik's, what is it that you don't understand? Rubik's, what is it that you don't understand? Okay, so very good. Yeah, that's good. So now I move to the next one. Okay, if you don't understand, make sure you go through the video. Now, the next method is precipitation. Now, I want to explain precipitation. And please listen to me and listen very well. Precipitation is all to separate soluble solids from a solution. Now, but the method is different. Now, let's assume we have a solution of iron 2 sulfate. This is a salt, FeSO4. This salt here is what we call iron 2 sulfate. This one here. Now, if I put iron 2 sulfate in water, okay, Now, iron 2 sulfate in water is what you get iron 2 sulfate solution. Don't worry, in maybe by next week or next 2 weeks, I'm going to teach you how to name compounds. So don't bother if you don't know it now. Okay, it's going to be a very interesting period. Just follow what I'm saying here. I like to say this first of all, that if you want to form a solution, just dip a substance in water, you have formed a solution. For example, if I take sugar and dip it in water and sugar dissolves in water, then I have a sugar solution. If I take salt, dip it in, put the salt in water and dissolve the salt in water, I have what we call salt solution. So when a substance dissolves in another substance, you call that a solution. Okay? Do you understand? That's how you form solution in chemistry. So solution does not mean you got it correctly. No. Solution simply means you take a salt and you dissolve it in water, or you take a substance and you dissolve it in water. You form a solution. Am I making sense? If you understand what I just said now, please indicate I understand before I continue. Okay, I like that. Now, Darasimi, to answer your question, it must not be water to be a solution. It must not be water. As long as you have a solvent and a solute, then you get a solution. And that solvent must not be water. Sometimes the solvent can be kerosene. There are certain things that can dissolve in kerosene to form a kerosene solution. Okay? There are certain things that can dissolve in fuel, right? Rubik's, go back to the video and watch it for you to understand fractional crystallization. We can't go back now. So that is what a solution is. So if I put a salt, this FeSO4 is called iron sulfate. Is a type of salt. And like I said, for now, you don't need to bother yourself with the names of salts. Just know that iron sulfate is a type of salt and it is soluble in water. If I dissolve iron sulfate in water, I am going to form iron sulfate solution. Like your table salt, the one we used to eat, it is called sodium chloride. If I dissolve sodium chloride in water, I have formed sodium chloride solution. So a solution is formed when you dissolve one thing into another thing. And it must not be water, it can be anything. Kerosene can be used to form solution. Petrol can be used to form solution. It can, and amazingly, the solvent can be solid, liquid, or gas. And the solute can also be solid, liquid, or gas. That means some gases can dissolve in solvent, in solid, some can dissolve in liquid, and vice versa. Okay? But what matters is that as long as one substance dissolve in another substance, you have formed a solution. As long as one substance dissolves in another substance, you have formed a solution. He goes what? Do you understand that? Please, I like to be sure you understand before I continue. Hello, do you understand it now? He goes what? I like to be sure you understand it now. Okay. Okay, Jack. Yeah. Okay, so now when you have a solution of iron sulfate, you can make the iron sulfate to precipitate. You force it out. And how you can do that is that look for a liquid that is miscible with water, but iron sulfate cannot dissolve in that liquid. Remember, there are two conditions. The first condition is that that liquid must be able to mix with water, is miscible with water. Then the second condition is that iron sulfate must not be soluble in that liquid. An example of such liquid is ethanol. Ethanol can mix with water. If you pour water and pour ethanol, it is miscible. You can't tell the difference. But iron sulfate cannot dissolve in ethanol. So if I have a solution of iron sulfate in water and I pour ethanol into that solution, you will notice that iron sulfate will precipitate. It will come out. It will be forced to come out. It's going to be forced to come out. So I want to check if I can see any video on that. And I will show that to you. Give me a second. Okay, please give me a second. I want to get a video. Okay, I'm sorry, I can't find it. I can't find it. I thought I would be able to see it. But before I continue, I'd like you guys to let me know if you understand what I just explained. So that is how that works. You take a solution of iron sulfate with water. If you want the iron sulfate to be precipitated, just pour ethanol. The iron sulfate will be forced out. So that is how that one works. Okay. Yes. Okay. I like the responses. I like the responses. Okay. Very good. Very good. Very good. Very good. Okay. So we are making progress. Now let's move to the next one. Now the next one is separation of immiscible liquids. That means liquids that cannot mix. Now I like you guys to write for me examples of two liquids that can never mix. They can't mix. I'll be waiting. Anyone you can think about, I'll be waiting. Water and oil, water and oil, water and oil. Beautiful. I love what I'm seeing. Water and oil. Oh, okay. Other examples can be kerosene and water. Kerosene can never mix with water. Petrol can never mix with water. So the way you separate good, the way you separate two liquids that are not miscible is by putting it in a separating funnel. This is what we call a separating funnel. This image you see here, we call it a separating funnel. Now, I want you to notice something. If you put like water, water is denser, so water will be the one at the bottom. Then kerosene will be the one on top. Water is always the one that is heavier. So now, I like you to see something. Look at the stop clock. No matter how you try to shake it, okay, they will still separate, right? Now, the only thing you can now do here is that you can now open the tap, the water will pour out, and what will be left is kerosene. I believe you understand that. Hey, somebody says sand and water. Is sand a liquid? Somebody says sand and water. That is village people. Oh. It is village people that will make you write sand and water. Okay? So sand is not a liquid. It has to be petrol and water, kerosene and water. So let me look for a video that can help us understand this.
more than 2/3 full. Also make sure to clamp around the ground glass joint at the top of the separating. Separating funnels are used for liquid extraction, also known as solvent extraction. They come in different shapes and volumes, but always ensure that you do
Please
not fill the
listen.
separating funnel more than 2/3 full. Also make sure to clamp around the ground glass joint at the separating funnel. Before transferring any liquids into the funnel, always ensure the stop clock is closed. When the tap is vertical, the stop clock is open, and when the tap is horizontal, the stop clock is closed. When pouring liquids, you may wish to use a measuring cylinder or long-stemmed funnel to prevent spillages. When both the solution and the extraction solvent have been added, layers will form. One layer is the aqueous phase and the other layer is the organic phase. Here we added colour to the aqueous and organic layers to show the separation more clearly, but it is more common for both layers to be colourless. The key to the separation of layers in a separating funnel is density. The bottom layer is the more dense solution, but this is not always the aqueous phase. For example, the separating funnel on the right has the orange aqueous phase on the bottom and the yellow organic phase on the top, because here ethylophanoate has been added to our aqueous solution of water. The density of water is 1 gram per centimetre cubed, but ethylophanoate, our organic phase, has a smaller density of 0.9 grams per centimetre cubed, and hence the organic phase forms the top layer. But on the left-hand separating funnel, the orange aqueous phase forms the top layer, and the bottom layer is the yellow organic phase. This is because an organic solvent called dichloromethane, DCM, was added to water, and DCM has a density of 1.3 grams per centimetre cubed. Hence, DCM is more dense than water, so the bottom layer on the left-hand separating funnel is the organic phase. In order to carry out an efficient extraction, we must ensure that the organic and aqueous layers are thoroughly mixed. We do this by inverting the funnel. To begin with, you should remove the funnel from the clamp or ring, holding it securely with both hands, and then turn the funnel upside down. When upside down, open the tap to release the pressure that may have built up during the mixing. Then, using both hands, invert the funnel 2 to 3 times before opening the tap to release the pressure again. To ensure maximum mixing and maximum separation, you should repeat the process of 2 to 3 inversions, followed by the opening of the tap another 5 to 10 times. Then securely attach the separating funnel back in the clamp or ring, and watch the layers begin to separate. This separation shows that the dye that we added has gone into the organic, which is why the bottom aqueous phase has lost its colour. Now it is time to extract the layers. Always start by removing the stopper from the... Open the tap and drain the first layer into a clean conical flask. Make sure you start to close the tap as the bottom layer drains out to slow the rate of flow and to help you correctly close the tap when you can no longer see the separation between the two layers. Put this conical flask to one side and collect the remaining layer into a new clean conical flask. To obtain the most accurate results, it is best to repeat the whole process twice more, by pouring back in the layer you wish to extract more from. In this case, we want to extract the organic orange layer, but this is not always the case.
Do you guys understand? If you understand the video, say yes, I understand. Let me be sure. But it's a practical example. Yeah, I need your comments. Good. I need more comments. Okay, good. Yeah, good, 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 good. 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 Water is more dense than oil. I already mentioned that. Water is more dense. Oil will always be on top. Water will be under. So I guess the issue of I guess this one is quite clear. So let's move to the next one. Now the next example is what you can use to separate. Miscible liquid simply means two liquids that can mix. The one we saw before now are immiscible liquids. That means they cannot mix. But in this case, the two liquids can mix. In this case, how you will separate them is called distillation. Distillation separates two miscible liquid using their difference in boiling point. It uses their difference in boiling point. That means you will boil the two liquids together. Before I continue, example of liquids that mix. Can you give me an example of liquid that mix before I continue? I want to be sure you guys are following. So give me examples of liquids that mix. You can write that down. Ethanol and water is beautiful. Yeah, I think blood dissolves in water. Yeah. Kerosene and water, no, 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 no. Kerosene does not mix with water. But a very good example is ethanol and water. So you use what we call a distillation flask to distill it. You boil the two, this is the diagram. You boil the liquid together. The boiling point of water is about 100 degrees Celsius. This is the boiling point for water. The boiling point for ethanol is about 78 degrees Celsius. That means when you heat this, ethanol own will reach first. That means ethanol will vaporize first. Then after some time, water will now vaporize. When ethanol vaporizes, it will enter this. This is called a condenser. Condenser is simply to cool it down so that it can become liquid. Now, let me say this. Remember, when a liquid reaches its boiling point, it will change to gas. So ethanol will turn to vapor and vaporize. Then it now enters this condenser. This is a condenser. The job of the condenser is to convert the liquid, the gas now back to liquid. And you can see that what we pour here is ethanol. Water will remain inside after some time. I hope you understand this. Water and ethanol. We don't need water and blood. So let me know if you understand this process. So distillation, like I said before, while you are letting me know if you understand it, distillation, like I said before, is when two miscible liquid, the water will remain in the flask. When two miscible liquids, you want to separate them. You want to separate a mixture of two miscible liquids. Put them in a flask like this. Heat it until it reaches boiling point. Ethanol will first vaporize because the boiling point of ethanol is 78 degrees Celsius. So ethanol will be the first to vaporize. Then when ethanol vaporizes, vaporizing means it turns to gas. When ethanol vaporizes, it will now go back into this, it will go inside this condenser, and from the condenser, it will turn to liquid. I told you that the job of the condenser is to convert the gas back to liquid. Okay, let me look for a video to play for you guys here.
When performing a distillation, first the condenser is filled with cold running water. Next, heat is applied to the mixture which is to be distilled. The mixture is heated until it boils, and the hot vapors will travel up the distillation head. Measuring the temperature of the vapors helps us to identify the liquid being distilled and will help to confirm its purity. If the vapors are pure, they will have a constant temperature equal to the boiling point of the liquid being distilled. As the vapors travel into the condenser, they will be cooled and will liquefy. The liquid droplets, called the distillate, run down the condenser and are collected in a receiving flask. A liquid can be easily separated from non-volatile contaminants by using a simple distillation apparatus such as this one. Since the non-volatile components in the distillation flask will not evaporate, the vapors and the resulting condensate will be pure. When performing a distillation, first the condenser is filled with cold running water.
Do we understand now? Enyoma, do you understand now? Yeah, I need your comment, please. Okay, so very good, very good, very good, very good. So now we move to the next one. Okay, there is another one that was not mentioned here. It's called fractional distillation. Now, the difference between distillation and fractional distillation is like the difference between crystallization and fractional crystallization. In fractional distillation, there are many miscible liquids together. Okay, Rubik's, what is your question? If you have a question, you can ask. Okay, while Rubik's is asking his question, the difference between fractional distillation and distillation is that in distillation, only two liquids are involved. But in fractional distillation, many liquids are involved. Many liquids are involved. In distillation, two liquids are involved. But in fractional distillation, many liquids are involved. Okay. Now Rubik's asked a question: how can two mixable liquids be separated? That's what I'm saying now. You can separate them using distillation, simple distillation if they are just two, or fractional distillation if they are more than two. Now, let me say something. An example of a case of fractional distillation is crude oil. The crude oil, crude oil is a mixture. Crude oil contains many things. Inside crude oil, we have petrol, we have kerosene, we have gas, we have diesel, we have bitumen. Many things makes up crude oil. So the only way we can separate the component of crude oil is by subjecting it to fractional distillation. And there is a difference between fractional distillation and normal distillation. I will show you the diagram. Please, I hope you guys are following what I'm saying. I hope you are getting what I'm saying. Fractional distillation is used to separate many when there are many, like crude oil or like liquid air. So let me show you how the diagram is for those of you that may want to see it. Okay, so look at this image. This is the difference. This part here, this F is called fractionating column. That F there is called fractionating column. That is what helps to separate different levels of liquids. It helps to separate different levels of liquid. So the difference between the apparatus used for fractional distillation and for simple distillation is just that fractionating column. And remember, it uses the difference in their boiling point to separate. It uses the difference in their boiling point to separate. It uses the difference in their boiling point to separate. Okay, so if you understand it, let me know. Say, yes, I understand. Yes, I understand. Okay, very good, very good, very good, very good. So that leads us to the last one. I already told you the job of a condenser. Now, can somebody, before I continue, can somebody tell me the job of a condenser? Who can tell me the job of a condenser? Who can tell me the job of a condenser? I'm waiting. Who can tell me the job of a condenser? To separate liquids, no. No. By turning it into gas and comes out liquid. Okay. Yeah, any other person? The liquid. I mean, the gas back to liquid. Yeah, I need more people. Annabelle, that's a good one. Yes, I need more people to tell me the difference. Okay, Enyoma says cooling gas to liquid. That's simply it. That is it. To convert the gas to liquid. To cool the gas to liquid. Remember that the ethanol that came out will be a vapor, will be gas. And so when it passes through the condenser is now what makes the gas to become a liquid. You know, I want to make sure that you guys understand this. Stanley says it cools the water, the vapor, and turn it to a liquid. Beautiful. Beautiful. That means you guys are following. Beautiful. Beautiful. Okay. I'm impressed. Okay, so that would now lead us to the next thing, chromatography. Now, chromatography is used to separate, you can write this in your notes. It's used to separate mixtures of solutes from its solution. Mixtures of solutes from its solutions like dye, pigments, paints, etc. That is what chromatography is used for. It's used to separate especially colored components like dyes, like pigments, like paints. Okay, that's what it is. And based on what I wrote there, it says it is based on different rates of movement of components between stationary phase and a mobile phase. Between a stationary phase and a mobile phase. Now listen, there are three types of chromatography. We have paper, that's the one that you should be bothered with. We have gas, and we have column. Don't worry, I'm going to explain it. Yes. You can use it to remove color pigments from plants. Yes. So you have paper. You have paper chromatography, you have gas chromatography, and you have column chromatography. Now, this is how it works. And I like the picture that I have here. I'm going to explain that, then show you guys a video. Now, look at this spot here. It is the ink. You put an ink on paper. And don't forget that ink is a mixture. That means there are many other things that makes up ink. And you want to separate it to know what makes up ink. Put it on paper, then dip that paper into a solvent like kerosene. The solvent must be a solvent that can climb up paper. I know some of you will be wondering, how do you know? Pick paper at home. That's a piece of paper like this. Put kerosene, dip the paper in kerosene, then be watching. You will notice that the kerosene will start climbing up the paper. It will start climbing up the paper. That action is called capillarity. Angel Fortune, yes. Chromatography can be used to extract paint from plants, yes. I said you should try something. You can take fuel, maybe petrol or kerosene. Kerosene is 4,500 naira for 1 liter now. When you dip this paper in kerosene, the kerosene will be climbing up. That process of kerosene climbing up is called capillarity or capillary action. You can try it at home, and I will try to play a video. Now watch. This is ink. Once this solvent starts climbing up and this solvent touches the ink, it will begin to dissolve it will begin to separate to different colors. And the reason for the separation into different colors is two things. Number one, so I like you to write that. So two things. Number one is that the components of the ink, all of them don't have the same attraction to paper. The attraction to paper is called adsorption, AD, not AB, but AD, adsorption. So all of them have different attraction. Now, have you noticed that you may have like 5 sisters let me use 3 sisters in a home, and different men are coming for their hand in marriage. Some girls will not even cry. They are looking for a way to run away from their home. So they follow the man and they are singing, "Oh happy day, oh happy day." Oh, happy. They are very happy. They have left their parent and they've left. Some people are praying for people to come and marry them. Then while there are some ladies that when a man comes to marry them, they begin to cry because they are missing their father, they are missing their mother, they don't want to go anywhere, they are dragging their feet. Why? Because each of those sisters have different attraction or different affinity to their parents. So some of them will be easily separated, but some of them will not be easily separated. That's the same thing with chromatography. All the components of the ink, yeah, is nature, is nature. Rubik's is nature. Some things are more attracted than others. Is nature. So the components are attracted separately, differently to paper. That one alone will make the separation possible. Then the second thing that makes the separation possible is that each of those components does not dissolve in the solvent equally. Some of them dissolve faster than others. You can even try this at home.